In a silent hall beyond space and time, the universe's first photons take their place. Nearly 380, 0 years after the Big Bang, when the cosmos is cooled enough for electrons and protons to combine into neutral atoms, light finally escapes its primordial prison. This light is the cosmic microwave background, a perfect, almost uniform glow that suffuses the heavens. But within that apparent uniformity lies a hidden melody, tiny temperature fluctuations differences of only 1 part in 100. Zero-where the notes of our universe's infancy. Each note is a density ripple, the seed of every galaxy, every cluster, every void we see today. In this silent opera, gravity conducts. Peaks of slightly higher density grow, drawing in gas and dark matter. Troughs become vast cosmic voids. The curtain rises on a hot sea of plasma. Photons scatter endlessly off electrons in a frenetic dance. Then, as the cosmic temperature dips to roughly 3.0 K, electrons bind to protons. Photons sans captive air suddenly free. They stream outward in a blinding flash, like the orchestra's opening chord. Inhomogeneities and density acoustic waves etched into the plasma survive this release, imprinting themselves as subtle temperature variations across the sky. Imagine sound waves propagating through the early universe's plasma, regions where photons push outward, creating rarefaction, followed by regions of compression where gravity pulls back. These oscillations form a series of harmonic peaks overtones in the CMB's power spectrum. The first acoustic peak tells us about the scale of primordial sound waves. The next peaks whisper of the baryon to photon ratio and the universe's composition. Together, they form a cosmic chord progression that describes matter and energy fractions, curvature, and expansion rate. Beneath the bright violin of photons lies the deep cello of dark matter. Invisible, non-interacting, it shapes the gravitational potential wells into which baryons fall. In maps of the CMB, its presence is inferred through the relative heights and positions of the acoustic peaks. It is the unseen baseline anchoring the symphony-guiding structure formation all the way to galaxy superclusters. On small scales, photon diffusion smooths out fluctuations, a process known as silk damping. Like the final decrescendos in a concerto, the tiniest notes fade away, leaving a smoother glow at arc-minute scales. This damping tail informs us about the epoch's thickness and the interactions between radiation and matter. The photons of the CMB have been traveling ever since, redshifted into the microwave band by the universe's expansion. Now sitting at a chilly 2.7 K, we observe them as a modeled sphere of light, a fossil record of creation. Those initial ripples have blossomed into cosmic webs, galaxies streaming along filaments, voids yawning between. The CMB's silent opera persists. Its notes still underpin clusters, its harmonies still echo in gravitational waves, and its memory still guides our cosmological understanding. In every direction, the sky's microwave glow hums that first great chord. Close your eyes, and you can almost hear the resonant overture that set the universe in motion. Far from our comfortable blue world lies an alien giant, so close to its parent star that its dayside roils in searing heat above 200 4C. This is a hot Jupiter, but unlike any we know. Its atmosphere is suffused with vaporized metals, its skies laden with silicates and iron. Here, rain is molten glass, storms are iron geysers, landscapes are forged from metal carved by scorching deluges. On the hemisphere facing the star, temperature soars until even rock vaporizes. Iron atoms lift off the surface, carried aloft in convective columns. Silicate dust and tiny glass spheres swirl in great billowing clouds, glowing dull red in the torrid light. Winds screaming at several kilometers per second chase these plumes, stretching them into elongated veneer-like clouds that drift toward the terminator. At the planet's twilight line, day meets night in a dazzling boundary. Here, molten iron cesspools of liquid metal, hundreds of meters, deep reflect the star's fury. Glass raindrops form in cooling updrafts, coalescing into droplets that grow heavy and fall. They rain sideways, whipped by hurricane-force winds, carving trenches and canyons in the metal plains. Each impact etches patterns that shimmer in residual heat, like glowing runes on an obsidian canvas. Cross the terminator into darkness, and temperatures plummet. Iron clouds condense into solid droplets, micron-sized pellets of metallic hail. They drift down to form frozen deposits along the night hemisphere, creating fields of silvery dunes under a sky devoid of sunlight. The once glowing landscape now gleams faintly in starlight, landing particles accumulating into dunes of iron-rich sediment. The planet's slow rotation, tidally locked, ensures these extremes never shift. Instead, energy transfer across the terminator drives jet streams thousands of kilometers long. Plumes of vaporized metal surge from the day side, then cool and collapse on the night side. These jets carve arc-like cloud bands that wrap the globe, visible in transit spectra as variable absorption features. Storms can merge, forming planet-scale vortice-iron cyclone-churning metal clouds into swirling tapestries. From light years away, astronomers watch this world in infrared and optical bands. Transit spectroscopy reveals absorption lines of FEI, SI2, and TI2. Phase curves brightness changes over an orbit map, thermal hotspots and cold traps. The flicker of metallic clouds drifting in and out of view hints at evolving weather patterns. In effect, we see the firefall, the molten deluge captured in starlight filtering through the planet's terminator. Over millennia, the star's relentless irradiation strips away atmospheric layers. Iron rains fall until the upper atmosphere is stripped to lighter elements, or until the planet spirals inward and is consumed by its star. But for now, it endures a living forge. Its skies an ever-changing spectacle of molten metal and glass storms. No life could survive here. Yet in its violence there is a stark beauty. Landscapes wrought from iron, storms of molten metal, dunes of metallic frost. This is a world that defies human imagination, yet reveals the breadth of planetary possibilities. It stands as a testament to the creativity of nature under extremes. These twin narratives, one of primordial light composing the grandest symphony, the other of elemental fury crafting metallic rainspan, the depths and the fires of the cosmos. Together, they fill 14 minutes of cosmic wonder, from the silent birth of structure to the violent artistry of alien worlds.